The process description shows that the combustion in the cylinders occurs within a fraction of the time of a revolution. Within this fraction of a second, defined by the flashes, about 100 grams of oil must be burned. A strong mixing of oxygen-rich cylinder gas into the oil, the so-called atomization, is a condition for the short time of combustion. Without a reasonable pump pressure level, mixing fails and the oil will not ignite at all, even though the stream passes right through a flame. If the pump pressure is raised to 80 bar, the oil is more finely mixed with air, but not enough to ensure reliable ignition. To illustrate this, an experiment set up with a pressure chamber and a high-speed film camera taking 3,000 pictures per second, showing how the mixing of gas into the oil is dependent on the friction between oil droplets and air molecules at a pump pressure of about 200 bar. First, a vacuum is created in the pressure chamber, and the high-speed camera shows the appearance of the narrow jet, which has an almost unchanged speed before it hits the bottom of the chamber. Then the vacuum is succeeded by a pressure of 3 atmospheres, and the high-speed camera registers the normal fuel jet with a wider spray angle, showing the result from the friction between air and oil that's injected under high pressure. Furthermore, it can be seen that the velocity of the injected oil slows down as it passes downwards of the jet. Returning to the ignited injections and using a pump pressure of about 200 bar, the atomization is now so good that all injections are ignited. At the same pressure and continued injection, a flame is formed, but the flame soon dies out because of the lack of oxygen at atmospheric pressure. In order to compensate for the much lower pressure compared to the cylinder compression conditions, air is now admitted through the pipe in the lower part of the picture, allowing the flame to keep burning. The flame is formed some distance from the nozzle. The distance between the nozzle and the flame is about 400 millimeters, at which point the turbulent flame speed is in balance with the speed of the jet, as could be seen in the pressurized chamber. Inside a working diesel cylinder with more dense air, all these processes are more intense and shorter distances are required.